Welcome to Pindar Poetry. We hope you learned something new.
You start by confirming prerequisites. Update drivers and firmware so the GPU can accept full workloads. Once done, switch power and thermal profiles to high performance and make sure fans and airflow are adequate. This prevents automatic downclocking. You should also terminate competing background processes and, when applicable, disable the integrated GPU or move rendering to the discrete card. These first steps give the GPU headroom. Now you can push resource allocation and scheduling deliberately. Next, you configure the software to target the GPU. Enable GPU acceleration in application preferences or set runtime flags for CUDA or OpenCL. Then, increase work granularity, bigger batch sizes, more parallel threads, or larger render settings to feed the GPU consistently. At the same time, profile execution with tools so you can see if the CPU, PCIe transfers, or memory copies starve the GPU. Once you identify bottlenecks, reorder tasks, overlap transfers with finally, validate sustained utilization. Monitor temperatures, clock speeds, and percent GPU use while running the target workload. If thermal throttling or power limits occur, tweak fan curves or slightly undervolt to sustain clocks. If utilization stays low, restart drivers, test with a different benchmark, and check for driver or OS-level power-saving features. Make sure you're not bottlenecked by disk or CPU. If a single GPU is fully used and you need more throughput, distribute work across multiple GPUs or instances.
Thanks for watching. Consider subscribing if we helped you.